Alright, so that's my first trial, and my name is Daniel Dallas, and I would like to go live for today. So just waiting a couple of persons for joining. And actually today's topic is about math recap, so GCSE, iGCSE program, that all types of equations. So all types of equations. So I'm currently streaming from the phone. It's not from the computer. So I'm using Streamlab right now. Actually, I tried Mobzen, tried live Mobzen, but for some reason it doesn't work. Maybe I'll fix that later on. So I decided to use that Streamlabs. All right. Someone joined. So one more time, I just want to tell you guys that this is my first experience to go live, because before, when I set up my channel, I decided to record videos useful for GCSE, iGCSE Maths, and right now I decided to go live. I want to test how it works. I want to test, is it possible to go first and do streams? Hi there. My first stream. All right. Hi, John. Thank you for joining us. Hi there. So, all right. Maybe it's good to start right now. This is about, first of all, what type of equations we are going to cover for today. We're going to cover linear equations and inequalities. So that's basics, and you know that linear equations should be written in the form x plus b equals c. So we also consider fractional equations that actually can be resolved using the crisscross ratio. Okay, so you set up the equation, you have two fractions, or at least you have to have that on both sides. And now what do you need to do? You just need to resolve by using the crisscross, alright? So that how it works for fractional one. We also consider power equations. And we touch maybe, I don't know, barely, or at least we consider several problems that actually designed to clarify your knowledge about how to use equations. So first about how to set up equation, and the second one is how to actually resolve using those techniques that you cover for the first three parts. Alright, so that's the purpose for today's session. I'll try to explain with several examples. I'll try to provide more examples in order you guys have better understanding. Okay, so just maybe waiting a little bit. Okay. Have time to drink tea for a while. Yes, I joined. Hey, did you find me in YouTube? What does mean now? You just need to go to YouTube on my channel, and there you can find it there. What does mean? No, that's it. You need to press play button because it's online, okay? It's live. So that's why actually you need to press the button. Play. And that's how you can see that. So if you're ready, just give me in chat some message so that I understand you are in, okay? Can you? Can you write me in the chat, okay? Why? You just go to YouTube. You just go to, wait, yes. Yeah, but I cannot see you, actually. That's the problem. Okay, so try. Alright, so I think it's right time to continue. Okay, so let's get started. So, solving linear equations and inequalities. So what it means? So basically what it means that for the first linear equations, we need to set up the equation itself. So I would set up in a way linear form. Ax plus b equals c. So that's the typical one. We have a and b and c. They are just numbers. They're coefficients. So a, b, c are coefficients. And x is the target variable that you actually need to find. So that's the target variable. Right now, it stays alone. It stays as the single variable. There are no other x's on other sides. So that's why this is a target variable that you need to express. So that's why what we're going to do, we need to use balance method. I'll show you the idea on first simple example. Let's say we have x plus 1 equals to 5. So that's pretty easy, and that's definitely like basics that you need to know. So x as the single variable here, 1 and 5 are just some numbers. You can say that if you compare with general model of linear equation, x plus b equals c, that's at least the form that you need to come to finally in order to express x later on. So you can say that coefficient a is the factor before x. So right now nothing stays here. However, we understand that actually coefficient a is 1. A is not 0, otherwise you won't have this term at all, because 0 times x will give you a result of 0 finally. Okay, so that's why a is not 0 and a is 1 in this case. So make sure you understand that. So coefficient b is 1 and coefficient c is 5. Alright, so that's pretty easy, and hopefully you understand how it works. Okay, so what about next one? Next step. I want to tell you how balance method works. What actually you need to do in order to solve your equation. So you need to solve and make x as the subject. So in other words, you need to say that x equal to some number. So where a number stays here. So number stays here. All right. How work out in this case, and how to use balance method, and the idea of balance method. So balance method is simply tells you that instead of equality, you can consider a physical equation or physical equality in terms of two plates of the scale. So let's say here and here are plates of the scale. So actually you hand the left side, that's the left plate here, and the right side, which is 5 in our case. So because you have equality sign, your plates are actually in balance. So what it means? It means that here you have x plus 1 on the left plate and 5 on the right plate. So what it means? It means that right now you have a physical balance. Okay? So what if you take away 1? What if you take away 1? So what it means? From both sides, of course. You just simply physically, you're taking away 1 from here, from that plate, and you're taking away 1 from the right plate to keep your balance. Okay? So you need to keep your balance. Okay? Sorry. Okay. So it means that you can take away the same number, no matter which. In this case, it's -1 because your final goal, you need to live with x equals. In other words, you need to live with x only. So that's why you're taking away 1. But to keep the balance, you also need to take away 1 from the right plate in order to keep your balance. That's actually the idea of balance methods. Okay? So after taking away, what you will have on the left plate, you will have just simply x stays alone, okay? And here, instead of 5, you will have just 4, okay? So in this case, you will have 4. And finally, actually, you understand which number stays here. So actually, this number 4 instead of x. So that's why on the left plate, there is x equals 4. And on the right plate, there is x equals 4. So this actually, I think it's pretty straightforward for most of the students. Like if you're on grade, I don't know, or year, let's say year 5, 6, or maybe 7, you need to understand how it works using this method, for example. However, for most struggling students who are actually doing, let's say, year 10, even year 9, they're not going to use balanced method, but they need to understand that balanced method should work, obviously, because otherwise you will actually break your balance, okay? You'll break your balance otherwise. So how to do it instead of like using and drawing those scales? How to try to do it like mechanically using just an equation? As you can see, we took away 1 from both sides to keep the balance. So, but technically, it works like you have an equation, x plus 1 equals 5, that's your original one. And you do what? You transfer this 1 to the right side, okay? You basically make a transition of the number that you don't want to have on the left side, and you transfer it to the right, okay? So that means you need, in this case, you need to swap the sign. So you take away 1, there is no 1 anymore here on the left side, and you put it to the right, so finally you'll get 5 minus 1 here, all right? You swap the sign for this 1, for this number, okay? So that how it works, okay? So you can calculate the result, and the result is 4. But technically it works the same. So if you put it and use analogy, so you can use the balanced method using scales and trying to practice first of all. If you're just start doing equations, linear equations, so you can use this method. It's pretty nice, and you can actually work with that. Okay, so let's maybe just go straight to example, okay? Let's go straight to example. For example, you have another one, and this is now 2x plus 3 equals 5. What are you going to do in this case? What are you going to do in this case? In this case, you simply want to do the same, or want to apply the same approach. So you have 2x right there, and before expressing x itself, you need first to understand what stays for 2x. So that's why, using the balanced method, you take in this 3 and transfer it to the right side, okay? So that's why you're left with 2x on the left side, and 5 minus 3, that's what actually be on the right side. So if you simplify the right side, you will get 2. And now you understand that for 2x stays 2, so that means just x equals 1 as the solution, and 1 exactly stays for, and this is exactly stays for your variable. Okay, I just want to add quickly description for the video. Just hold on. So right now, you can try to solve pretty similar, but however, we will have -1 instead. I will say that's equal to 4. Title's weird. Okay. Seems to me that I'm streaming into different video. I don't know why, but actually it looks a bit interesting for now. Okay, so I added something. I hope it works right now. Yeah. All right. So what we're gonna do here? So we see the target variable 2x, and we want to simply transfer -1. So why -1? Let's just remember balance method again, so that you won't have any questions after that. So let's say you have plates of your scale, and here you have 2x minus 1. So right side is just 4. So using the balance method, what actually you want to do in order to stay with 2x on the left plate only. So what exactly you need to do? So you actually need to put extra 1, because -1 and 1 together will kill each other, and that means it will leave you with 2x. With 2x on the left plate, okay? So it means you have 2x on the left plate. But because you added 1 to the left plate, so actually on the right plate, instead of 4, you will also, or you should also have +1, extra 1 that you added, because you need to keep balance, okay? Keep the balance. So this is equality between two parts, okay? So that's why on the right side you will have actually 5 instead. And this is your equation. So that's why when you transfer, actually, and you see that you want to transfer a number which has negative sign right now, it means that you actually need to take not just 1, but the whole number with negative sign. So you take away -1. So that means you take away exactly the whole number with minus sign. You can't leave minus somewhere in the air, right? You cannot like be on the left side and so that it didn't attach to any number. So otherwise you will have 2x minus and what? Minus something. There is no 1 anymore, okay? So that's why, okay, you taking away -1, and technically means that when you transfer to the right side, you actually need to change the sign to the opposite. So that's why if you transfer, you will have +1 instead on the right side, okay? So that's what we actually did here. We killed 1 and this way, so that we left with 2x, and on the right side we will have 4 + 1, which is actually 5, okay? So that's why technically you doing the same stuff, you leaving 2x on the left side, and 4 plus 1 will give you 5. Okay? But actually, if you're in year, let's say 7, 8, or on top of that 9, you actually use this method. This is just illustration why it works. Okay, so finally we have 2x equals 5. How to find x? Yes, you understand that 2x, so for those who are pretty weak with just basic operations, is simply you have 2x that shares the number 5. So that's why what stays for each x, if that's going to be the same number, obviously half of 5, right? Because you're sharing 5 between two x's. So that's why instead of x, you should have 2.5, okay? That's decimal number. Okay. So let's go to more advanced stuff. That would actually, we consider the idea of the balancing methods, yes? And now let's try to consider how it works like for more advanced examples. All right. So stay early. So that's why we just go there, and we want to, what I'm going to do. So I just want to copy that, and okay, here we go. Oh, it's better to, I think, do one more copy for that. Yeah. All right. So right now we need to try to solve more advanced examples. So for a while I just want to erase this to clean up this area, because we already know how it works. So just one more time. Okay. Okay. So maybe it's better to clean like this. And just in case, to copy that. Yeah, so guys, sorry, but this is my first experience to go live, and that's why I'm trying to, this is actually error and trial methods, alright? So what we're gonna do, we just want to copy that, right? Okay, so right now we are here. Okay, so to more advanced stuff. What we're gonna do, we are going to consider this example. Let's say 9 plus 2x, and let's take negative 11. All right, how would you solve that? You need to solve for x. So solve for x. Okay, solve for x. Try to do that. Okay, so 9 plus 2x equals negative 11. What we're gonna do here? So we just need to define the target variable and target term, the term that contains your variable x. And what we're gonna do right now, we are going to transfer it. We're going to leave 2x here and transfer a number 9, which stays nearby. Okay, So that's why what we're going to do, we can leave 2x as it is and transfer 9. You remember when you transfer 9 to the right side, you'll get -9. You swap in the sign, okay? So what are you going to do? You just need to simplify the right side. So you'll have 2x, and on the right side, you'll have -11 and -9, okay? -11 and -9. In total, you'll have -20. From where you can solve for x simply by dividing both sides by 2, okay? So that's why on the right side you will have -20 over 2, which is -10, okay? So that's how it works. This is how it works. And that's how it works for linear equations when you have negative numbers. No problem. Numbers might have different signs. Okay. So let's move next. So let's move next and let's consider another example, which is a bit more maybe struggling. So 3x minus 1 equals to 5, okay? So what do you do in this case? So you take 3, you multiply by x minus 1, and the result is 5. So what are you going to do with that? You just simply need to, there are two ways actually how you can solve. Your variable is right there in the brackets. So that means you can immediately divide both sides by 3. And that means you'll have x minus 1 left here, and because you divided by 3, 3 and 3 in the bottom part will be cancelled, as well as you should have 5 over 3 on the right side. Okay. So next up, how to transfer. So you transfer normally, you take in minus 1 and transfer to the right side, okay? So simply, what you're going to do, you just take -1 and transfer to the right side. So you'll get x equals to 1 plus 5 over 3. All right? So it will work like this. Okay, and now you just need to add. Just remember, make sure you are able to add fractions. So right now, instead of 1, you're just doing a fraction 3 over 3 in order to add. So you adding them as normal fraction with the same denominators. That means it will leave your 3 in the bottom as the common denominator, okay? Because the denominator is the same, so you don't touch them, and you put the whole, like the single common line for the fraction, and you add in 3 and 5. Okay, you add in numerators. So that means, in this case, you simply doing addition, and you'll finally get 8 over 3. If you like, you can convert into mixed number. So in this case, if you just make sure you remember how to do this. So you're trying to divide 8 by 3, and the nearest number that is divisible by 3, that is lower than 8, is 6. So you take in 2, then you multiply 3 by 2 back, in order to see which number actually you had. So you will have 6, right? And taking the difference. So the difference to 8 is 2. So that's your mixed number, while this is improper fraction. So this is the mixed number. So this is the mixed number, okay? So that's how it works. Okay. So next up, what you can do. So what you can do, we can try to go to another one, which is called solving linear equations. We have repeated unknown. So what does mean repeated unknown in this case? So repeated unknown means x stays in maybe in different parts of the equation, but it repeated. For example, let's consider the first one. First of all, sorry, I just want to create a new sheet here. All right. So let's try so that we have another blank sheet. Okay, and now let's say that just in case we have 2x minus 1, and let's say that will be equal to 3x. Okay, so what we're gonna do in order to solve these equations, we need to identify repeating unknowns. So repeated unknown in this case is x, but it's too early to simplify, just trying to combine them. So because the primary goal is how to solve is to combine them in one part, okay? So that means before doing that, you need to expand brackets. So that's why the general goal, so the goal, in this case, goal is to combine all x's and one side, okay? Just to combine them. Means just collect. But before simplify in terms of expanding brackets. So before expand brackets. Okay. So how are you going to expand? Just simply as in previous case, you just taken 2 multiplying by each term that stays inside. So you'll get 2x minus 2 and the result will be equal to 3x. Okay. Now you see that you have repeated unknown 2x and 3x. That's more clearly. And now you need to transfer in that side, which gives you, so I recommend to calculate so that the final simplification will give you positive number before x, okay? So that means you take in 2x and transfer to the right side, okay? Why? Because let's compare. If it transferred to the right side, you'll get negative 2 equals to 3x minus 2x. And now you simplify, so you'll get 3x minus 2x. It is simply 1x, okay? Equals to negative 2. Or, obviously, it's better to flip it over and say that x is negative 2, okay? That's your solution. And let's compare with the case if you decide to transfer 3x to the left side. Just compare. 2x minus 2 equals 3x. And now you decide to take 3x and transfer here, while you need to have negative 2 and transfer to the right side. So let's see what you will have in this case. You will have 2x minus 3x. And when you take negative 2 and transfer to the right side, you will have swapping the sign. That means you will have positive 2, okay? So it means that it works in this way. And the first trouble that you will have is that you will have negative x instead of normal x. And the second part, you need to take the number itself and transfer it to the right side. So I recommend to use the, the methods after analyzing before. So analyze, what if you transfer 2x to the right side? Hopefully you'll get 3x minus 2x, and that means it will give you positive x. That's okay. So try to transfer in that side so that to have positive coefficient before final x, okay? Because in this case it will work better, okay? Because here you need now swap them back. You take negative x, transfer to the right side, you take in 2, transfer to the left side, so that to get x equals negative 2. And then you again swapping them. So as you can see, this method, when you decide to transfer, let's say improperly, that's okay, that will work, but it will cause some, inconvenience. All right. So that what is called repeated unknown. When you have several unknowns, the unknown, it's the single one is still x. We're not going to solve equations which has several variables. In this case, we're still solving with one single variable x, but however, in this case, those x might be repeating. So I hope you understand that. And let's try maybe to solve the following one. So let's say you have 7x minus 4 equals to, let's take 3x plus 2. Okay. So let's try to do that. Let's try to do this. And the way you actually do, let's accelerate a little bit. First, you need to expand brackets. So you take in 7x minus 4. But on the right side, you need to expand the brackets, means you need to multiply out 3 by each term that stays inside. So you'll get 3x plus 6, all right? Then you decide to which side you need to transfer, in other words, where actually you are going to collect your x's. So I would recommend to transfer 3x to the left side, because you'll get 7x minus 3x. Okay, and that will give you actually 4x, which is positive, and this is wave cool. And you take a negative 4 and transfer to 6. So that's why the right side is going to be 6 plus 4, because negative 4 will change in sign. Okay, so it will work like this. So finally you have 4x after simplification and 10 here. How to find x from there? You just simply need to divide both sides by 4. Okay, so that's why you'll have 10 over 4. So if you like, you can start canceling. If this is sort of mental assignment, it means you need to accomplish without a calculator, but no problem. So you can do that. You can cancel 10 and 4 by 2. You're left with 5 over 2, and now obviously you understand that this is 2.5. Okay, all right, so next part. So that's solution. So next part, what if you have sort of fractional coefficient? Let's say you want to solve this sort of equation. Say x over 2, say plus 2x equals to 1 over 3 times x minus 1. Okay? In this case, you just normally works, you need to work with fractional coefficients, no problem. The idea stays the same. First you simplify, you expand in brackets, and then you combining or collecting x variables on one side. So what it means? It means that here you have x over 2 and 2 over x. So it's better to go to improper fraction. So x over 2 plus, instead of 2x, it's better to make improper fraction with the same denominator as you have here. Okay, that's the first way how we can resolve these equations which have actually fractional coefficients. So just go through the fraction. However, I'll give you a more simplified version how you can do in order to get equations with whole coefficient, whole integers, let's say integers coefficients. Okay, so on the right side you still have 1 over 3 times x. You need to expand brackets, minus 1 over 3. But as you understand, so this way actually a bit more struggling because you need to work with fractions, and it's always harder than works with, let's say, integers. So you do what? You add in the left side, which gives you 5x over 2, and you cannot do anything, so you also can transfer x over 3 to the left side, because your goal is to collect variables on one side. So that's why you'll have this, and on the right side you will have negative 1 over 3. However, how to resolve next? So you need to make difference as fractions. All right, so you taking 5x over 2, you subtracting x over 3. So you need here to work out the common denominator, which is 6. You simply taking 2, multiplying by 3. And the fast method is just go crisscross. So this 3 goes here as extra factor or as a multiplier, and 2 goes here. So that's crisscross. So 3 goes that way and 2 goes that way. Okay. So right now you'll have 5x times 3, which is 15x, and you still subtracting x multiplied by 2, so you get minus 2x. Okay. What you will have on the right side, still negative 1 over 3. Okay. Next one, 15x minus 2x, you'll get 13x here over 6 will be equal to negative 1 over 3. And right now what I recommend to do crisscross multiplication as normally how you resolve ratios. So this is a ratio, and right now how to resolve, you can multiply 6 by 1 or by minus 1, so let's crisscross, and 3 goes there. So it means that you'll have 3 times 13x will be equal to negative 6, because it's going to be 6 by negative 1. Okay, so right now you'll get 13x equals negative 6. That's how it will work. Okay. Okay. So let's simplify that. 3 times 13x, you'll get 39x. And on the right side, you'll have still negative 6. Okay. And finally, you need to divide both sides by 39. So you'll get negative 6 over 39. All right. So that's your answer, but you can still simplify if you like. Negative 6 over, so your 39 is actually 3 times 13. So you can cancel by 3. And finally means you'll get negative 2 over 7. Okay. However, as you understand, this is quite, maybe inconvenient, What does mean inconvenient? Because you use fractions. So what we can do here, so we can try to change that and say, okay, instead of using fractions, you want to get rid of them. So what you can do, you can multiply both sides by the common denominator of what you have here and here. So basically by the maximum number that make your equations to be cancelled, I mean in terms of fractions. So in this case you want to get rid of 2 in the bottom part and 3 in the bottom part. So you trying to find LCM of 2 and 3. Okay, so you want to find LCM. How to find that? Pretty obvious. So 2 and 3 are primes, so that's why you want to do what? You just want to multiply by 6 because LCM of 2 and 3 is 6. So let's see what you will have. This is alternative way. So actually I show the first way, which actually takes pretty long stuff and it takes longer time. So what I just recommend to use another approach that I'm showing right now. Okay, so I multiply by 6 both sides and I will have 3x. Each term I'm multiplying by 6, so plus 12x. And on the right side I will have 2 instead of 1 or 3 because 6 and 3 will be cancelled, so I will get 2x minus 1. Okay, so now what I'm going to do, I'm just going to simplify that, and finally I'll combine 3x and 12x. That makes me having 15x, and on the right side I just simplified it, so 2x minus 2. Okay, and now I can express x by combining this x, this 15x with 2x. This simply linear equation with repeated unknown. No, basic equation for that. So that's why you transfer 2x to the left side and you'll get 13x equals to negative 2. From where we can get negative 2 over 13, which actually the same answer, but however you see that it takes much less time in order to get finally to your answer. Okay, so someone new joined. Hi there. So we are doing linear equations right now, but actually the topic is to go through several types of equations. So you can see here, solve linear equations and inequalities, fractional equations, power equations, and problem solving using equations. This is primarily for GCSE and iGCSE, so you can consider as, you know, entry-level basics. However, we can enlarge our scope, and this is part 1. We're not going to consider quadratic equations. We are not going to consider like power equations with power more than actually 2, so not quadratic, not cubic. So that's why we're just doing pretty simple like basics. For if you do have like any questions, so we can switch the topic because you guys there are only 3 persons watching right now, and actually I'm trying to stream the first time. So before I was used to recording video, and actually you can visit the channel, there are pretty lots for GCSE, iGCSE, higher maths, like foundation as well, so you can explore the source. And actually I started doing A-level, so let's check it out. If you have like maybe any questions for a specific topic, like you would like to discuss within the algebra, maybe quadratic equations, maybe, I don't know, any other stuff, so please welcome. You can share in live chat. Okay, so we're just coming back to solving linear equations, and right now, as you can see, we recap how to work with repeated unknowns variables and how to solve basic linear equations. Now we wanted to know how to cope with fractional equations. So this is a ratio resolving method. So actually the method that you apply in the ratio, okay? When you're solving ratios. Just remember, you actually did it several times when you struggle with different ratio problems. You remember like quantity and some like of some substance, or probably ingredients and substance as related as x to y, and that's relation as 2 to 3, okay? However, here we are going to consider fractional equations. So that means we will have only one x variable, okay? X variable. And this should be only one instead of two like this way. However, the idea stays the same. So x to y is the same as 2 over 3. So what it means? It means that those ratio you can consider as fractional equation. So let's consider the case when you have simple fractional equation x over 2 equals to 3 over 2. It's pretty the same that we considered here with coefficients. However, this is a bit simplified version, just x over 2 equals 3 over 2. So how to resolve that? So example 1, how to resolve that? We just simply need to use a crisscross multiplication. That's the easiest way that works every time you have two fractions and you have somewhere the variable, okay? So I'll show you the first way, which is actually pretty like natural and what you probably learned in your schools. So you take in crisscross multiplication, and first you convert into linear one. So 2 times x you'll have in the left side, and 3 times 2 means 6, okay? You'll have 2x equals 6, from where you can resolve by dividing by 2. So 6 over 2 is 3. That's the solution. However, you can change the idea how it can be done. So for example, what you can do, instead of doing crisscross, first of all, let's have a look where x stays. So x stays here. So that's why you want to say that, okay, I want to stay with x on the left side. And what about the right side? So you have 3 over 2, and you apply crisscross method, but for only 2 which stays here. So you carry your 2 to the right side to the top, okay? So in this case, you will get 2 times 3 and over 2. And now you just simply can cancel your fraction because you have 2 on the top and 2 on the bottom. So that's why you just cancel that. And that means you'll have x equals 3, the same solution. So maybe here the advantage is not pretty like obvious, okay? However, for more complicated examples, it works pretty like nice. The advantage is obvious. So for example, you have another equation which has 3 here, let's say x plus 1 here, and on the right side it's going to be 5 over, let's say, 2. How to resolve that? Again, you need to define where your variable, and your variable is within the expression x plus 1. So that's your target expression that first you want to express. So what do you need to do? You just need to put this x plus 1 to the top, so you swap with 5, okay? 5 goes down. And also you can carry 2 to the left hand side to the top, because when you're resolving ratio, always from bottom through the equality sign, the bottom number goes crisscross to the right top. as well as here. 2 goes to the left top, always to the top. But if you like to transfer, like in our case, if you transfer the top part of the fraction, like 5 in this case, it goes down actually. So that's why it's called crisscross, okay? Crisscross multiplication. So that's why after swapping, you'll have x plus 1 on the top. You can write x plus 1 over 1 if you like, but because you just swap with 5, there is no need to write x plus 1 over 1. So 5 goes down, as we agreed to do. So 5, you swap x plus 1 and 5, and 2 goes to the top, so you'll get 3 times 2. And this is almost the solution, okay? Because you'll have 3 times 2 over 5, that means you'll have 6 over 5. And you want to say with x on the right side, so what are you going to do? You need to transfer 1 to the left side, okay? So you transfer 1, and that's how you will stay with x, okay? It works like that. It works like that. So 6 over 5 minus 1, you need to simplify, but I'll rewrite as x first, as goes first, and here on the right side, I will have 6 over 5 minus 1. So 6 over 5 minus 1 will give me the following. So instead of 1, I'll use the fraction 5 over 5 in order to make the difference easier, okay? We have common denominators the same, so we're taking 6 and 5 as a difference, and finally we will left with 6 minus 5 is 1 over 5. Okay, so that's the final answer for our equation. This was example 2. Okay, so guys, if you want to try by your own and try maybe to give me the answer, so I can give you another example 3, and you try to accomplish by your own, okay? If you're able to write any like answer in the chat, that will be okay. So you need to solve that. So this example 3, and right now we are going to do that. So example 3. So let's say you have maybe a bit more, let me see, yeah, this one. We combine a ratio with a repeated unknown, and right now what I'm going to write is 1 minus 3x over 4, let's say, equals to x minus 2 over 2. Okay, so try to solve that. I think it's pretty natural, like it has the high resemblance with we discussed for 1 and for 2. So identify target variables, try probably to make crisscross, try to swap them, so that in order to get your axis on one side. However, we have repeated variable, it's here and here. So the best way is to make linear equation first of all. So just hint, just go to linear equation, all right? So try do this. Okay, so I'll give you the first step here, and what I'm going to do, I'm going to take the bottom one, 2 here, and 4 here, and make a crisscross transfer. So I will have, so from there, I will have 2 times 1 minus 3x, and the right side will have the following form, 4 times x minus 2. Okay? So now you have simple linear equation with repeated variable. Okay? So that means you're able to simplify and write the following stuff. So you expand the brackets, you'll get 2 minus 6x, and the right side will have the following form, so 4x and minus 8. From where you again identify the target variable, it's here and here, and you're thinking about on which side you want to collect. Because this 6x will have negative sign, it's better to transfer this negative 6x to the right side. Okay? So that's why you will have, so finally you will have 2. So negative 8, you take and transfer it to the left side, you'll get, swap the sign, so it gets positive 8. And right side, when you transfer negative 6x, you'll have 6x here, and 4x together will give you 10x. Okay? 2 and 8 will give you 10, will be equal to 10x. So the final answer, x equals 1. Okay? Because you divided 10 by this 10, and that's how you working out the value for x. Okay? So x is 1, and that's okay. We actually solved this. And we can go next. That was fractional equations. So make sure you understand that. So let's consider power equation. Before we go into probably more complicated case, let's consider power equation. So let me make a copy, fast track. Okay. So, all right, we are here. Okay. So, what fractional equation represent? They represent x to some power, let's say a, and the result equals to some another number. Maybe instead of a, I will use power n, and that will be equal to some number a. I think it's better. So for example, let's take x squared equals to 4. Let's take perfect number. Okay? This sort of equation, they are not linear. They might be linear in case when x equals 1, it becomes linear. It becomes linear. However, in case n more than 1, let's say n equals 2, 3, and so on. So I've just taken positive integers, so that's why I'll say that n is from z plus. That how I denote positive integers. So in this case, I just simply want to notify that in this case 2, 3, and other powers will give you different types of equations, but definitely not linear. So it becomes linear, but for n equals 2, 3, and so on, it becomes non-linear. So that's why non-linear for those values for n. Okay? So it's done. And let's consider this example, x squared equals 4. We need to resolve that. And we need to take how to resolve. So either by guessing, if you like. So we can do by guessing. However, you can also use another form of solving. You're taking the square root from both sides, okay? So you're taking the square root from both sides. So in this case, x is going to be equal to 2. However, in the case of power equations, if you taken the root with even power n, so n is even, in this case you'll have your final result as plus and minus, because let's just pretend that we want to check. So let's check it. Let's plug positive 2, so 2 squared, it's 4, that's okay. And let's plug negative 2, so negative 2 squared. So negative 2 squared is by definition negative 2 times itself. So you times negative 2, and that will give you 4. Okay, that will give you 4. In this case, you understand that negative 2 also works. So that's your general way how you can find x as unknown. So you've taken the square root in this case. But general solution for general case x to the power of n simply looks like, so for x to the power of n equals a, you're taking the nth root from both sides. It means finally you'll have nth root of a. Okay? So, for example, if you have, in case n equals 2, you should take plus minus square root of a. Let's pretend that we have another power, which is 4, and we have the result 16. Okay. You can use this approach in order to find the value. So you're taking nth root, so you're taking the fourth root out of 16. You can use calculator with fourth root, but however, you can use the power properties. In which way? You remember that 16 is simply 2 to the power of 4. Like 2 times 2 times 2, it's 8, and times 2, you'll get 16. So in this case, you've taken the fourth root of 16, and that's the same, you've taken the fourth root of 2 to the power of 4. So what it means? It means that finally you'll get x equals 2. However, if you try to test negative 2 in this case, it will also work, right? It will also work. So for example, if x is negative 2, you raise to the power 4, and it will also give you 16. So that's why the general strategy is to take plus and minus sign, and minus sign you taken in case n is even. Okay, I mean, you taken plus and minus in case of even. If it's odd, so your solution is just normally nth root of a, and if n is odd. Okay, that was the basics for power equations. Now let's try maybe to practice with a bit more complicated one. So for example, let's take, first of all, x squared equals to 13. So obviously in this case, x might take both values. Okay, so you're taking the square root of both parts, so final solution is square root plus minus square root of 13. If you use, for example, let's assume you want to calculate 3 significant figures. In this case, if you use calculator, because this is a rational number, square root of 13, yeah? You need to use calculator in order to have a decimal form. So 3 significant figures is going to be 3.61. Okay. Or that's the same to two decimal places. So they are the same in this case. Okay. What about equations? Another example that originally you have fractional one, so sort of mixture. So you have x over 2, and let's say right side is 5 over x. Let's take, okay, 15 over x. Okay, so you will get fractional 1. How do you resolve this? You just simply need to use crisscross multiplication. So you take in 2 multiplied by 15, and you take in x and multiply by x. So like this, okay? So we'll get x squared equals 2 times 15 is 30. And right now you have the power. So you have power equation. Okay? So while before you had fractional 1. Fractional. Okay, that's how you can easily convert into power equations and now make just rearrangements in order to get your x value. So you take an x, you take in the square root, and that's how you can find two values, square root of 30. If you need to calculate, just go and do that. Alright, so that was actually examples of power equations, and it seems to me that's okay. So I think the problem solving we'll discuss next time. So problem solving, I'll just set aside for probably maybe another stream. I don't know. I haven't decided yet. But actually, I have this on my channel, so you just please explore the source. And that was my first stream. Okay. I use Streamlabs. I'm not sure it's okay or not. I'll see if it will be saved. And after uploading, I just want to see how it works. Alright. So it's done. Thank you for watching. That was Daniel Dallas. Explore the source, and you'll find definitely lots more. And see you later. I want to stop that. How to stop this?